used to give me roses. I wish she could again. But that was on the outside, and things were different then. We built our world together. We're love so clear and strong. But that was on the outside. Where did I go wrong? On the inside, the sun still shines, and the rain falls down. But the sun had rain of Christmas too. When the morning comes around, last night I dreamed we were together.
Good evening, everybody. Welcome to Gazing at the Galaxies Volume 2. I don't think I'll ever get sick of that introduction. It's a cracker. But before we take you beyond the Milky Way and out into galaxies far, far away, I'd like to say that in the spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to the land, sea and community, and we pay our respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today. Tonight, the Astronomical Society of Victoria is proud to bring you our Gazing at the Galaxies Volume 2. With lockdown continuing for so many of us, and surprisingly, we've got some clear skies with no moon either to spoil the view. We thought we'd take the opportunity to focus on galaxies tonight. So grab a drink, get cozy, sit back, and enjoy the ride as we bring you a selection of galaxies from beyond the Milky Way. The first object for the night will be NGC 3621. But before we have a look at that, we'll bring in the team. Welcome, everybody. We're all here.
Hey, how you going?
Hey.
Hello.
Hi, I'm Steve.
It's going to be a long night.
Yes, you are.
We will we'll jump into NGC 3621. It's an object that Caleb has been imaging while we've been in the back of house. He's been taking some images of it before it dropped below his line of sight. So, Stefan, would you like to tell us a little bit about NGC 3621? Because we think you might be the only one who knows anything about this one.
Yeah, well, look, I wasn't anyone who knew anything about this until probably about 20 minutes ago. But there are some really beautiful facts about this galaxy. So you can just about make it out, in the middle of the photo here. And I think, Caleb, correct me if I'm wrong, have you been pre-imaging this one already?
Yes, I have.
Yeah,
This is
so
a stack
it
of
really...
13
2
minutes.
13 2-minute shots. So yeah, I think it really goes to show how dim this galaxy is. Like most of the galaxies on that we'll be seeing tonight, it's an incredibly distant object, and most of these galaxies aren't very intrinsically bright. Some of them are, and you'll really see them when we see them. But this particular galaxy, it's what we know as a field galaxy. So it's sort of off alone by itself out there in intergalactic space. It's not really associated gravitationally with any specific cluster of galaxies. So it's a little bit of a loner. But one benefit of that is that its spiral structure hasn't really been disturbed by anything else coming and interacting with it, colliding with it. So it's really got this sort of beautiful, really sort of almost grand design spiral galaxy structure with these beautiful arms. So it's around 22 million light years away. So pretty damn far. And we can see it in the constellation Hydra. It contains some 20 billion solar masses. So it'll have, some 100 million stars within it. So another interesting tidbit about this galaxy is that it there's not many interesting facts about this galaxy, apparently. No, it has a very active galactic nucleus, which typically indicates that there's some black hole. And in this case, we do have evidence that there is a supermassive black hole in the core of this galaxy, around 20,000 solar masses in size. So not an exactly really massive, supermassive black hole, but a very large black hole as far as they go. And yeah.
Not much more to say about the first one.
I think Stefan mentioned that it's in Hydra, so it's fairly low in the southwest, and heading lower as the evening goes on. So I think this was an object that we had to catch fairly early before it disappears. So particularly, this is Caleb's view, isn't it?
Yep.
Yes, this is.
So it must be very low for you up there in
It is
in Brisbane, I guess.
It's probably, what was the number again? NGC 3621.
Yeah.
It's currently 14 degrees. So that's below my imaging capabilities.
Good comment there from Neil Creek. Thanks, Neil.
All right. Now, I think we might, since we don't have much more on that one, we might move across to, I think Andy was going to try and do the Small Magellanic Cloud. Andy, were you? No? He's shaking his head at me saying, no, can't do that one.
Well, I'm in the middle of getting, I'm doing the same. If you can see on my image, I've got the same.
You're on 3621 as well, are you?
Yes, and I've got 20 minutes of exposure, 10 stacks of 2 minutes.
Oh, there we go. Let's jump across to that. So this is one you're in. This is the same galaxy.
Same galaxy, yep. Oops. Let's zoom in on it a bit.
Now we have a question on equipment. Chris wanting to know what equipment you guys are using. So I think we'll talk about Caleb and Andy's equipment. So Andy, what are you using for this particular image here?
It's a Skywatcher 6-inch Newtonian, and I'm using a DSLR camera, an old 450D on this one, and on a HEQ 5 mount. But the main imaging is from my DSLR camera, so it's been modded. It's had its IR filter pulled off, and I've only this is the first night I've got it after I've had it all back together from being smashed, and it's the first test, and it's working quite well. Lucky.
Is that the one that blew over in the wind?
Yep.
Oh,
yep.
Glad you got it working.
It was in pieces. It was in pieces up until about a week ago, and yeah, it seems to be working fine. There's no darks been subtracting off this, so this is just a straight
image.
2 minutes stacked. Yeah, 10 times 2 minutes stacked images.
Andy, do you want to explain you talked about a modification to your Canon DSLR? Do you want to explain what that is and what it does?
Well, you pretty well strip it down right down to the sensor. All DSLRs have got an infrared filter on it for bright sunlight to stop because the sun's so bright, but that also cuts out infrared channel pretty well, and because the sky is so dark and there's so little light coming through, you need to remove this to let all the infrared come through. So during the day, it's not a good day camera, but at night it'll let through a lot more photons, which will end up being an image, and especially with the hydrogen alpha, which comes straight through. So when you're mainly doing nebulas, you'll get all the deep, the hydrogen gas all around, but normally an IR filter would cut out quite a fair bit of it with a standard DSLR.
Thanks, Andy.
Now, Caleb, you've been imaging this one as well, obviously. So what's your equipment? I think you've got yours on the screen there. There we go.
Yep. So I'm using a Skywatcher 8-inch Newtonian, so just a slightly larger version of what what's your name? Sorry, Andy.
Andy.
Yeah, what Andy had. Had a mind blank for a moment. We're currently using a ASI 294MC Pro, which is a dedicated astronomy camera, riding on a Skywatcher EQ6R.
Who's got the cat in the background there?
Someone's cat.
I thought I was on mute.
We had a visitor. We did say this was going to be a light-hearted, fun stream.
Sorry.
It's okay.
You can hear.
So, we jumped to the next one. That's it. So, how much time did it take to take the image? So you've got 13 2-minute stacks of this one.
Yeah, so for my particular case, for this particular image, 13 images of 2 minutes each. So that will be 26 minutes in total.
Yep.
Of total integrated time. But in general, we usually do a lot more than 26 minutes. We do hours and hours, sometimes over 24 hours per image.
It's about standard run for Anne-Marie, I think, 24 hours an image. She does some pretty long runs. They come up looking pretty good though. So now, shall we move across to the next object then, which is the Sombrero Galaxy?
Oh, it's me.
Swapping around.
Yes, just because we flipped a few around because Caleb's just with his location. Caleb's up in Queensland, sunny Queensland, in lockdown as well, and his balconies have limited view of some of these objects. We kind of tweaked a few just so that he could image them with us as well. So this is Sombrero. Now, Steve. Oh, sorry, I am Steve. Would you like to take the reins on this one?
I can start a little bit. Just some basic information. So this is the Sombrero Galaxy, which is it's a Messier object. It's M104, and the reason it's called the Sombrero Galaxy, as I think you can probably see in the image there, is it looks a bit like a sombrero hat. So it sits in the constellation Virgo, and it's part of the Virgo cluster of galaxies, of which there's a lot of them. And it sits distance-wise 28 million light years away. So it's a fair old distance away. One of my favorite objects to look at. I can find this object in a suburban sky visually. So with my 10-inch Dobsonian telescope, I can normally find it. It won't appear like this. It will appear as a little fuzzy blob. So visual magnitude is 8.12. So well within the range of a 10-inch Dobsonian, but it's really down to how much light pollution you have. Up at our dark site, on a really clear night, through my 10-inch scope, I can see that dark dust line. So I might hand over to Stefan just to pick things up. I've given a bit of some basic information about it there. He can probably explain a little bit more about the galaxy itself.
Yeah, so just a little bit about its classification, M101, M104, Messier 104. It's actually, one little interesting fact about that is that Charles Messier, the namesake of the Messier catalogue, only actually added 103 objects to his catalogue. But this is M104, and that's actually because he sort of discovered it. He noted it down, but he didn't classify it as anything within his catalogue. So it was actually added after, posthumously, after he'd already died. It was added to his catalogue afterwards. So I think it's the last, or one of the last objects in the Messier catalogue. Just a little bit about the galaxy itself. So it's what's called an unbarred spiral galaxy, but it's got a bit of a peculiar structure. As you can see, there's a really, really definitive dark band of gas and dust. And it's actually thought that band encircles the galaxy, and it's got this sort of really big halo, which you can see that it encircles. So it sort of looks, to me, a bit more like a UFO than a sombrero. I don't really see the tip of the hat. But the entire galaxy itself is around 50,000 light years in diameter. So it's around a third of the size of the Milky Way galaxy. So it's a little bit smaller. Just one other interesting thing about the dust lane that encircles the entire galaxy is that in the optical wavelengths, so the wavelengths of light that we see with our eyes, that we can image with our visual cameras, you can see that dust lane is very dark. It's obscuring light from behind it. But when professional astronomers image this galaxy in other wavelengths, it really highlights some of the interesting structures within it. And particularly, the most interesting to me is in infrared light. If you Google search Sombrero Galaxy in infrared, what you'll see is that the ring of dust that encircles the galaxy actually glows really brightly in the infrared. So it really looks like this super alien sort of glowing ring just encircling this sort of faint galaxy. It's really bizarre and quite beautiful to see. I've definitely got a bit of envy being able to image galaxies in infrared, but who knows, maybe one day.
So,
Is there some debate, Stefan, as to whether the Sombrero Galaxy is sort of transitioning to be an elliptical galaxy rather than a spiral galaxy?
Yeah, I definitely read a bit about that. I haven't gone too deep. I'm not sure the consensus at the moment, but yeah, definitely, it's sort of that weird in-between stage where it's got some sort of spiral structure. You can, in high-resolution images, say by the Hubble Space Telescope, you can definitely see some of that spiraling structure, but it does have that big elliptical element to it. And yeah, whether or not it'll transition completely into an elliptical, I'm not 100% sure, but yeah, something that happens, definitely.
So just a quick one. Our Deep Sky Section Director wishes he was running the 40-inch tonight. When he says the 40-inch, he's talking about our 40-inch telescope at our dark sky site. We were meant to have Deep Sky Section tonight. We probably would have been looking at this through the 40-inch, wouldn't we, Steve?
We would. I was going to say, I wish I was looking through the 40-inch scope tonight and up there with Paul. We made our plans, but unfortunately, COVID gets in the way.
Yeah, sometimes COVID spoils the fun. Now, we have a question. What galaxy is this? This is Messier
M104, the Sombrero
Galaxy. And call it the Sombrero Galaxy because it looks like a sombrero side on.
I like Stefan's UFO Galaxy.
It kind of does look like a UFO, doesn't it? It's got a bit of UFO about it. Technical question. I have a Cassegrain F12. Do you think it is even possible to do deep sky photography with it? Otherwise, I would use my Newton F5. Greetings from Germany. Hello, Germany. Glad to have you on board, Tommy.
Guten Tag. Guten Abend.
Yes, guten Tag.
Yes,
Is it afternoon there? Is it afternoon? Guten Abend. Wie geht's? Kann ich Ihnen helfen? Mein Name ist Mark. Wie heißt du? That's
Sehr
about
gut.
as far as my German goes.
8:21 p.m. Mark.
Oh, guten Nacht.
No, that's right. I just thought you were asking me the time.
In Germany,
So Germany's going to be about 8 hours earlier than us, something like that, 8 or 9 hours. The UK is 9 hours. I think Germany's probably 8.
It's
8
about
hours.
midday then. So it's good Abend. There we go. Sorry, Tommy.
To get to your question,
my German was horrible there. I stopped in year 9. So. Take it away, Stefan.
yeah, no. To answer your question, absolutely. As you can image basically anything you want with a Cassegrain F12, but of course, with a Cassegrain comes a lot of focal length, and that introduces challenges to imaging. When you're dealing with a lot of focal length, your image is essentially your field of view is very, very narrow. So you need to have a mount that's able to track very accurately, and you'll likely need to be auto-guiding in order to image without getting your stars trailing. An additional challenge of using a long focal length like that, imaging at f12, is that it's not going to be bringing in a lot of light. With galaxies, you can sort of get away with it. Galaxies are sort of a bit more bright as deep sky objects go. But yeah, if you're going to image with an f12 system, you'll need a long total exposure time and long sub-exposures likely. I would be more than happy to image with your f5 Newtonian. Usually an f5 Newtonian's got a decent bit of focal length as well. So as long as you pair that with a camera with nice small pixels, then you can get out some really nice resolution out of that system as well. So you can do either, and it sort of comes down to the accuracy of your mount, I would say.
A very, very good explanation. Gavin, you are right. If we were looking through the 40-inch, we know what Paul would be looking at. He'd be looking at the dual box cluster. It's his favourite. And now I'll wait for my phone to beep with a message. Now,
it's usually a word beginning with B.
It'll be a nasty message, I'm sure. We'll move along to the next object, which is Centaurus A, the hamburger. We've got Lee's got his hamburger he's been working on. He hasn't eaten much of it, thankfully.
Much like the others at the moment. That's what it looks like outside at the moment. So
you've got a patch of cloud moving through. So
yeah, it's skipping quite a few frames, but so that's 18 minutes.
Oh, that's 18
minutes.
There we go.
Yep.
All right, Steve, I'll hand this one over to you as well. And before you start, hello to New Zealand. I don't know how to speak the native tongue of New Zealand, so I won't even try. But glad to have you aboard. All yours, Steve.
So Centaurus A is, guess what? It's in the constellation Centaurus. Fairly close to us, actually, as galaxies go. This is one of the nearer ones that there are sort of middle distance ones that we'll be looking at this evening. We've got some pretty close ones, a few middle distance ones, and then some a little bit further away, like the Sombrero. This is quite a bright galaxy. It's visual magnitude 6.64. Did I say 12 million light years away? One of the, I always think of this as one of the sort of the objects that kind of everyone wants to look at because it definitely does look like a burger in a bun. It's a great object. So it's a special type of galaxy called a lenticular galaxy. And you can see the burger in the bun is actually a huge dust lane running through the galaxy. Stefan's going to talk more about this, but it's a massive source of radio activity as well. Well, perhaps Stefan, talk about that a little bit. I know you've got quite a bit to say about this one.
Yeah, absolutely. So this is another example where the universe is sort of teasing us as humans because our eyes are extremely limited, right? We've evolved on on Earth, and we've become accustomed to the light that the sun outputs and that is visible on Earth. And so our eyes are particularly sensitive to light in what we call the visible spectrum of light. So, you're familiar with the colors of the rainbow. That makes up visible light. But that's not all the light that there is out there in the universe. Like I was talking about before with the Sombrero Galaxy, being able to see that in infrared wavelengths reveals some hidden structure. There is some hidden structure within this, the Centaurus Galaxy, in another wavelength, in particular X-ray and radio waves. And of course, we can't see this with our eyes, and our commercially available cameras and sensors aren't sensitive to those wavelengths, so we can't image those. But if we were, what you would see is perpendicular to the dark dust lane of the Hamburger Galaxy, you would see these great big plumes of what look like gas and dust spraying out, but it's really high energy radio waves. And actually, Centaurus A is one of the brightest sources, I think it is, apart from the Milky Way, the brightest source of X-rays in the night sky. And all of this high energy output of X-rays and radio waves is due to a super massive black hole right in the core of this big disturbed galaxy. So there's a supermassive black hole, and it's around 55 million solar masses. So 55 million times the mass of our own sun. And some really interesting news that just came out. If you're able to share my screen, Mark, I've shared it to you. Are you seeing my screen?
There you go.
So you see the header of the paper? Do you?
Event Horizon Telescope observations of the jet launching and collimation in Centaurus A. We can indeed see that.
So this was released just recently, back in July. The Event Horizon Telescope project was, or is, a collaboration of radio telescope arrays covering the entire globe, and they all work together to form one big sort of interferometric telescope. And that's what was used to generate the first image of a black hole that was released a few years back now. But the interesting thing about this is that just last month, they released the highest resolution image of the jets surrounding the black hole within Centaurus A. And so this is this image here. So down in the left-hand corner, you can see Centaurus A, that hamburger structure with the radio plumes coming out, as I was talking about. And the inset image, the red jets that you see, this is actually the relativistic jets surrounding the black hole in the core of the Centaurus A galaxy. So this is just a fantastically beautiful image that recent technology has just given us the ability to do. And so this image is at about the resolution of the size of the of our solar system. So it's a very, very high resolution image, and that sort of prominent V shape poking out to the left, these are the plumes of high energy radio waves that are being emitted as a result of material surrounding the black hole. And so what's actually happening is the black hole in the core of the galaxy is actively feeding. It's bringing in material that's falling into it. And as material, as gas and dust accretes around the black hole, it spins up really, really, really quickly. And as charged particles move in sort of an angular motion in a spiral, they release a lot of radiation called synchrotron radiation. And that's actually the source of all of this this radiation that's being outpoured here. So yeah, that's what I wanted to say about that. It's really, really interesting image, I think. It shows some very, very interesting asymmetry.
That's a great picture. I like that. Mentioned
I'm just like going back to the whole. It was going to be a very fun and light-hearted stream tonight, and now my head hurts.
Hey, well, here we go. I'll bring the tone down a bit then. I mentioned earlier on that it's quite a bright galaxy. It's actually the 5th brightest galaxy that we can see. So, do you want to know what? Do you want to guess what the brightest galaxy is that we can see, other than the Milky Way?
The Large Magellanic Cloud.
Correct. What's the second brightest?
The Small.
Correct. What's the third brightest?
I'm going to go with Andromeda.
Correct. Oh, you got Mark. What an
I'm on
excellent.
fire tonight.
Do you know what the fourth one is? A bit harder. And
Triangulum.
you're right. I thought it might be
Marie for the Clean Sweep.
NGC 553, but it's not. It's Triangulum Galaxy, which is M33. Is it M33?
Is
That
that
is
on our
correct,
list tonight?
And then Centaurus A is the next brightest one. But I suspect NGC 253 must be up there with them. That's a bright. We'll be looking at that one later on.
I'm surprised M83 is not there.
Yeah, surprising, isn't it?
Well, I'm glad that I got those correct. Now, so we might now move to Southern Pinwheel. M83 is our next object.
Oh, no doubt.
And welcome to our Herald Sun viewers. Glad you can join us tonight. We're in the midst of live stacking galaxies using astronomy equipment. So for those who didn't see, we've just finished up on a hamburger galaxy, which is Centaurus A. We're now moving across to the Southern Pinwheel, Messier 83. So while the guys move across, we might stick with Caleb because he's got the view at the moment. And we'll
There's just one more thing I want to say about Centaurus A galaxy.
Yeah.
For any of the astro imagers out there, one really good challenge is that surrounding the Centaurus A galaxy, there's actually a bit of hydrogen emission. It's incredibly, incredibly faint. But I've seen some people pull it out in their images, with many dozens of hours of exposure time. But it's a really, it's a nice challenge. If you're looking to image this galaxy in a novel way, try and pull out some of the hydrogen alpha.
Okay. Challenge accepted. Well, not for me anyway, for the others. So, jump across this. So now you've moved across to M83.
Yep, that is the core of M83.
That is the core of M83. Now, before we jump in further, I just thought I'd do our usual, what's going to becoming our usual. If you are liking what you're watching tonight, and we hope you do, if you we've got this wonderful stars thing on our Facebook now. You can donate stars. Apparently, it's a donation that comes to us and helps us put these streams together. And every little bit helps. It keeps us being able to do these as often as we can do. And obviously, the longer we're in lockdown, the more of these we're going to be doing because there's not much else to do. But all of the funds that do come to us go to our All Abilities astronomy project that we're working on at the moment. We've just installed a motorized gate up at our dark sky site so that you don't have to exit the car anymore to open the gate to access the site, which is great for those with limited mobility. And we're also in the process of constructing wheelchair accessible and mobility accessible pathways around the site. And our All Abilities telescope is under construction. So we now just need to get the roll-off observatory constructed on site for that telescope, and that observatory has a warm room in it as well. So for those who feel the cold, for the younger people, for the elderly, people with those mobility issues, you can come, you can sit in a chair and look through the telescope. You don't have to get up the ladder anymore. That's the goal of this project, is to bring astronomy to more and more people. So the stars help us, through Facebook anyway, help us get that goal. Now, who'd like to start talking about M83? Steve? I am Steve.
Yeah, I hope, Steve. I'll do just a bit of an overview, a few of the facts. So, magnitude of this is just over 7.09. So I think this must be pretty close to being in the top 5 of brightest. It's another of these sort of reasonably close galaxies to us. It's 15, 16 million light years away, so relatively close. It's a barred spiral, which hopefully we can see on the picture that you'll be bringing up. Perhaps not
I can
yet.
see those. I can
We can't
see
quite
those.
see the bar.
Yeah, not just yet. He's got to add more stacks to it. That's only one stack, but I can actually already see the spirals just in there.
Yes, I can see the spirals as well.
Yeah, and this image will get clearer and clearer the more images that are stacked on it. There we go.
Yeah, so you can definitely see the bar there. Apparently, it's an intermediate barred spiral. So I'm assuming intermediate means it's sort of got a sort of a medium-sized bar on it. It's definitely one of the showpieces in the night sky, but it's one of these wonderful objects that only us down south can see. It's in the constellation Hydra, but too low in the sky for Northern Hemisphere viewers to see. It's a face on, obviously, as you can see here. Beautiful object. We may start to get some colour coming in as we capture more photons. But in the spiral arms, you can see some of the beautiful sort of bluish areas, which are where they're star-forming areas that with new stars in them, and then towards the center you get a sort of yellowish color, which are the sort of more mature, more established stars. So I don't know whether Stefan wants to expand on that a little bit.
I think you've pretty well covered it. It's just a beautiful example of a face-on spiral galaxy, and I think everyone is a sucker for face-on spiral galaxies. Edge-on spiral galaxies, really beautiful, nice, don't get me wrong, but face on, you can see all of that intricate spiral structure, all of the arms sprawling out from the center. It's just fantastic. And don't forget that we live in a galaxy much like this, a spiral galaxy, and it's a disc-like spiral. It's sort of like egg-shaped or frisbee-shaped. It's a little thicker in the center, but our own Milky Way galaxy has around 4 major arms and a couple smaller spurs coming off. And just recently, actually, I could have brought up another paper, but there was some research that was done with some radio telescopes observing in the hydrogen line at around 21 centimeters, which is a radio source. And the astronomers were able to infer that there was actually another arm in the Milky Way galaxy even further out and sort of a lot more dim. But I don't think there's any visual observations of that arm yet. I think it's mostly just inferred from radio observations.
What's interesting, I find, with this one is that it's not one of the brightest objects in the sky, and yet Charles Messier from Paris was actually able to catch it. It must have been really low to the horizon for him. So I'm amazed that he managed to catch it. I know I mainly do visual astronomy rather than photography, and face-on spirals galaxies can be quite difficult to see. You kind of lose some of the light because it's face on. When they're edge on, you've got the sort of a thin, brighter sort of line of light that you can see. Face on galaxies can be a little bit harder to see. So quite surprising that good old Charles managed to see this with his little refractor, I think it would have been, all that time ago.
Would,
I think-
would you also
I think-
would you also expect though, Steve, that there's a huge difference in the 1700s to now in terms of light pollution and even the Industrial Revolution, which threw so much,
Good point.
what would you say, particulates into the atmosphere that we'd have to fight our way through now.
Yeah, that's a good
But he
point.
wouldn't.
So what I like about this is 3 1-minute images, Caleb.
2 minutes.
2 minutes. So this is 6 minutes, and the detail that we can see already is quite astonishing, really. So it's a 6 minutes. Every image that adds onto this is a 2-minute exposure. So he's got 3 lots of 2-minute exposures, and we can already see, the bar, the arm, the spiral arms, the core, the detail in this for such a short exposure. That we're watching unfold live in front of ourselves right now.
Caleb,
I
are
do
you
want to-
using a color camera?
Yes, I'm using a color camera. I do want to add, I'm using a dual narrowband filter, which is you're not supposed to, but for the sake of being able to see anything due to the local light pollution, that's the only thing I can do to put a dual narrowband filter on to cut back a lot of the light pollution or light bands that are associated to light pollution. However, that also means I'm cutting out a lot of the broadband spectrum. So that's why I can see a lot more details, but at the same time, I'm getting a lot less light.
The reason I asked that, Caleb, is I think I can now see some of the blue areas in the outer spirals, but sometimes it kind of, because I know it's there, it's sort of in the mind's eye, but I think I can see some bluish tinges to the outer spirals.
You can just about to see the entire
that
cloud
in particular
around there.
there, I can see blue there.
Caleb, your solution is to just shoot out all the lights.
I know, right?
Amanda wants to know, what is it? That is a galaxy. That's what that is. That is Messier 83, a southern pinwheel. How far away was it again, Steve?
It is 16 million light years, 16 million light years.
16 million light years.
So it's actually a relatively close galaxy to us at 16 million light years.
Just a long way to go to get to it, that's all.
It's probably that good walk that we need when we're in COVID lockdown. Oh my God, it'll break the 5 kilometre distance. Oh,
it's a lockdown exercise walk. That's what it is.
just getting out of bed feels like 15 million years walk.
Takes about that long. Now, I'm not sure whether anyone's got the next object lined up and ready to go or not. So we had NGC 55, but Anne-Marie, I believe, is still trying to align. Start to polar align. That's the word. I will get it out. So we might have to sort of jump over that one, unless she's got it. Unless she's ready to go. Are you ready to go, Anne-Marie? She's not. No, I'm putting the pressure on.
Got the pressure on all of us here. We're hunting around.
Pressure, eh?
Especially if he jumps to the next one after that and no one's anywhere near it.
No, probably not. Is that this is?
Sorry, I lost my StreamYard. I lost my StreamYard. I couldn't find it.
She's back.
I'm actually on M83, but I've only got one shot.
Would you be able to jump across to the NGC 55?
No, because that's a 10 o'clock target.
Oh, that's a later one.
I'm going to scoot down to NGC 7424. I'm going to head over there now.
Done. You go down to that one. We're going out of order again. That's what we do. We did say it was going to be a lighthearted bit of fun stream. So
while we're talking there, I can just explain that there's a group of galaxies that call the Sculptor group that we're going to be looking at. But the challenge is that they're just currently sort of rising over in the sort of southeast. And so NGC 55 is actually very low to the horizon at the moment.
Yes, that is what we're battling. We finally got clear skies, but now we're battling galaxies that are low on the horizon. Can't win, can you? We're just trying to see if we can get. So while we're going, this is now 10 minutes worth of exposures on M83. So you can see that detail even more in there now. Might be able to see someone standing on a planet waving back at us soon. Anything's possible. So I think I'm just wondering, Lee, would you be able to get Barnard's galaxy, or you got cloud still?
I'm a bit back and forth. Let me just have a look. It's coming in droves. I'll move over there.
Yep.
I was able to kind of get it if I have, quite a lot of exposures. It starts to show up a bit more. So I'll move over there now.
Maybe jump over there and start looking at that one. In the meantime, we might Actually, we might watch you move over there. How's that? Let's do that. Let's show what happens, what this is all about.
Oh, all right. Was that Anne? I think that was maybe
That was
Anne-Marie's
Anne-Marie, the cat again. I just quickly muted her because waiting.
I've
So is that
actually even before,
NGC253?
this is I was about to go to Barnard's, but this is on 4945 at the moment.
Oh, okay.
Which
there
I've
we
never
go.
seen before, but I think it's this here.
It is that there.
Yeah.
That is indeed what it is.
Right.
So there we go. We're gonna have a look at NGC 4945. It's looking a little bit green at the moment, but Lee will tidy that up, and he will.
That's only 1 minute, and I'm not guiding at the moment because
The patchy clouds.
effectively, yeah. So unfortunately, at the moment, with the guiding, the moment it gets a little bit dodgy, it starts trying to over guide, which means it ruins the stack. So it's pretty much better if I leave it and let
So you just tracking
let
at the moment.
Sharpcap do its thing. Yeah.
Yep. All right. So there is a very faint. It's almost like on an angle from. There we go. That's better.
You can see some granularity in it now.
You can get some grainy clarity. So this is NGC 4945. So boys, take it away.
Well, this is another one of those galaxies where there's not quite that much information available. So what we do know is that it's approximately 11.7 million light years away, and it's another galaxy located in the constellation Centaurus. It's actually a barred spiral galaxy, sort of like the like M83 that we were just looking at, except this time it's seen almost edge on. So you don't see any of that face-on spiral detail. You don't see any of the arms picked up, at least not in the images we've got at the moment. But you can definitely see that sort of that streak, that line of the galaxy coming across. That's magnitude 9.3, so it's not one of the brighter galaxies. I'm not a visual astronomer, well, not a lot anyway, so I can't really tell you whether you'll be able to see this in the binoculars or telescope, but I have imaged it before, and you can definitely tell that it's one of those galaxies where you need a little bit more exposure time. One interesting thing about it is that it has an active galactic nucleus, and its nucleus is emitting a lot more energy than other galaxies like it. And because of this, it's suspected that there's a supermassive black hole in the center of the Milky Way, really churning things up. So here in this color image, you can see a bit more of that structure. And if we can zoom into the galaxy a little bit more, you'll see some of the definition in color between the outer edges with that sort of those younger, hotter, bluer stars, and then towards the core, the more mature, old, reddish, yellow colored stars, which is fairly typical. A lot of star formation occurs in the spiral arms where a lot of gas and dust is being churned up and smashed together. So yeah, you can definitely see it's a pretty peculiar looking galaxy from our perspective, and I believe its common name is the Tweezers Galaxy. Like so many other objects out in space, I don't really see where that comes from, but maybe you can.
No, but we do have a very interesting question. Christina, who's one of our star donators, thank you, Christina. Are there any of these galaxies metal high or metal low in comparison to our galaxy?
Good question.
Yeah.
Stefan,
Put you on the
is this
spot.
about the age of the galaxy? So, and stars and things like that we were talking about in one of the previous sessions that we had.
Yeah, exactly. So I'm not sure. I'm not sure of the specific metallicities of the galaxies that we're looking at. I'm sure it's something that you can find out there in the literature, but it's not something I typically want to talk to people about because it's not something most people are interested in. But to those in the audience who aren't sure what we're talking about, the metallicity is the measurement of atoms within the galaxy that are not hydrogen or helium. So I'm a chemist. So when I look at the periodic table, I see every element as an individual element. But astronomers look at a periodic table and they see hydrogen and helium, and then everything else is just metal, basically. And that's totally fair. There's not a lot of chemistry that goes on out in space, or not on appreciable amounts that they affect anything out there in space. And most of the material out in space is hydrogen and helium. I believe it's something like 70% hydrogen, 25% helium, and then a smattering of the rest of the elements. And so when the universe was first formed, it was basically just that. 75% hydrogen, 25% helium, and basically nothing else, no other heavier elements. And these heavier elements come about as stars form, and in their cores they undergo nuclear fusion and fuse those hydrogen and helium elements into higher atomic mass elements. And so as a galaxy ages and matures and gives birth to more stars, and those stars die, the metallicity, the number of elements in that galaxy that are not hydrogen and helium, slowly start to grow. And so that's one way that astronomers can measure the age of galaxies, is by measuring their metallicity.
There we go. I hope that answered Christina's question.
So I talk about Stefan was talking about looking at this object sort of visually. So this is one of the really good objects to look at when you're up at our dark sky site, the LMDSS. Certainly, you can see it pretty good through my 10-inch telescope. You can see some probably similar actually to that image that you're seeing there on the screen. 4945 is a big object because it's not that far away. It's as Stefan said, I think it's something like I don't know, 11 million light years away. It's a really great object to look at through the 40-inch scope, and it's part of this wonderful group of galaxies and well, one or two other objects as well. It's very close to Centaurus A and M83. They're all in the same part of the sky in Centaurus. Also very close to Omega Centauri. So there's a really nice bit of sky there to look at. Through the 40, you would certainly see what I call the granularity that you're starting to see now, which is that sort of difference in the light and the dark areas of the galaxy. Similar to, it's not quite as good as NGC 253, the Sculptor galaxy, which we'll have a look at, I think, later on once it rises a bit higher. But it's a very, very nice galaxy to look at.
So I think this is 2 stacks, Anne-Marie was telling me just before in the chat. This is 2 stacks. The first one was 2 minutes. And the second one is just a 60-second stack. Now, Anne-Marie, would you like to tell us what equipment you're using to be able to get such a high-quality image from 3 minutes of exposure?
Yeah, it's not bad, is it?
Pretty good, yeah.
It's a 10-inch Newtonian reflector, and so that's f5, so it's rather fast. I've got the ZWO ASI 1600 Pro, which is a monochrome camera, which is a bonus. And I'm on the Skywatcher EQ6R mount. This isn't tracked either. I mean, it's tracked, but it's not. Yeah, I'm not guiding. Yeah.
Okay.
No.
That's very impressive for an unguided 3
So
minutes.
that's 3.
Well,
should be
4
3
minutes
now.
4 minute exposure.
Mm.
I'm glad your sky's cleared up.
No, actually, it's obviously clouds coming because that one made it duller.
Yeah.
So they must have a bit of cloud on that last one. Yeah.
Looking good. Very impressed. So I think we've covered all we can cover on that one. Now I'll just have to see what the guys are up, what the team's up to. Okay, so we've got, while we wait for the clouds to clear in Ringwood, where Lee is, we've got NGC 5746.
This is still
This is
same.
still, it is tweezers, yes.
That'll be next up.
That was a mix-up.
Yep.
You're
I'll
making me
swing
look
over
bad now.
in a minute.
We have another question while we're waiting for the next one to run through. I'm going to jump back across to Anne-Marie's one there because I do really like the look of that one. We have a question from Graham. A random thought, and the random thoughts are the best thoughts as far as I'm concerned. We see this galaxy as one object, but as it was mentioned earlier, it's made up of many millions of stars around which could orbit many planets supporting life, some form of life or none. What do you reckon the chances are of life on in this galaxy? I mean, I know we need to keep it light, but I've just really thrown a heavy question out there.
Look, it's not astronomy if you're not talking big questions.
No.
So I think this is one question that we've had before, and I think, you know, as a scientist, it's hard to speculate in the absence of data, and the best way that or the best estimate that we have at the moment to try and estimate the number of intelligent civilizations that are out there in the cosmos is what's called the Drake equation. So you can Google this yourself, but what you'll see is that it's a fairly simple equation, just a number of factors multiplied by each other to give the probability of, or the number of probable intelligent civilizations that are out there. So that comes down to a few different things. So, you know, how many stars are, or how many galaxies are there in the universe, and how many of those galaxies have, you know, sun-massed stars? How many of those sun-massed stars form planets around them? So how many planets are there in the universe? How many of those planets are rocky planets and are potentially able to foster liquid water? How many of those go on to develop, you know, single-celled life or something like that? How many of those single-celled life forms develop into multicellular organisms and then on into more sophisticated life forms and then intelligence? And within that equation, there are a lot of unknowns. You know, there are some things that now we can get a fairly good estimate of. We know roughly how many stars there are in the universe and how many of those stars should have planets, how many of those planets should be rocky planets, and we're just about starting to get an estimate of how many of those may have water and may be able to generate life. But of course, even up until today, we only have evidence of any life-like organism or molecular machine existing on one planet, and that's Earth. And until we have evidence of that existing elsewhere, we really can't answer any of those last variables. So it's hard to speculate, but given just the sheer number of stars out there, the sheer number of planets, even if the chances of life arising are 1 in a trillion, 1 in a million trillion, given the large number of stars that there are, those tiny chances balloon out to almost certainty that there is life elsewhere in the universe. Whether we'll ever be able to detect it is another question, but I think this is one of the things that drives us as astronomers, is that we want to know the answers to these questions.
I think we can all wake up now. No, that was actually a really good answer.
Oi.
Sorry, Stephen, I'm being cheeky here. No, it was a very good answer. But I like the idea of the Drake equation, and I like the fact that you can just make up whatever bloody number you want, stick it in there, and you're not wrong. You can't be wrong. It's whatever you want it to be.
I think the numbers, for me, make it pretty certain that there's going to be a lot of intelligent life out there. Almost as certain as that there will always be people who refuse to get vaccinated.
Oh no, we're not going there. Let's not go there.
It's a Drake's equation. So it's a Drake's equation versus the Fermi paradox.
It is.
Yes.
It's a battle between two at the moment, isn't it? Now, while we're waiting for the next lot of objects to either get high enough or to not be behind clouds, we had on our list the small and large Magellanic clouds, or as my daughter likes to call them, the magic clouds. So this is an image that Andy, or Yondu, has taken, and it shows 3 galaxies in one. It has the Milky Way, it has the large and the small Magellanic Cloud. And Neil, thank you for answering that question. I was going to get to it, but you've beaten me to it. So Neil's answered a question about flocking your OTAs for better contrast for one of our viewers, and he's answered it for us. So thank you very much, Neil. So, Steve, I'll let you take this one away. Let's not go into life on other. No, we can't.
Is this Daddy Bear, Mummy Bear, and Baby Bear? Is that...
it's kind of like Hannibal Lecter, really, when you think about it. It's like he's just eating other galaxies up.
I'll talk a little bit about the small Magellanic Cloud. Because I happen to have brought the info up in Sky Safari about it and just found some.
You're telling everyone your secrets now.
Oh no!
Need to watch us. All I need to do is
all transparent. For me, it's an interesting one. This because the large Magellanic Cloud and the small Magellanic Cloud are probably the most well-known of the, I'll call them satellite galaxies that sit around the Milky Way. The little baby SMC there is, for me, often gets overlooked as compared with its bigger brother, the large Magellanic Cloud. Although I have to say that and I think you can see it in the view there. What I usually go to the small Magellanic Cloud to do is not to look at the small Magellanic Cloud, but to pop down to 47 Tucana, which is the globular cluster that you can see there just below, second brightest globular cluster. But the large Magellanic Cloud and the small Magellanic Cloud are, as I said, probably the most well-known of the satellite galaxies of the Milky Way. The large Magellanic Cloud is a little bit nearer. It's 160,000 light years away.
Before you jump to the large, this is an image that Anne-Marie's taken of the small Magellanic Cloud.
Okay, I'll talk about the small now. The small is about 200,000 light years away, and talking about satellite galaxies, it's actually the 4th nearest neighbour of the Milky Way. So it's not the sort of the the second nearest neighbour, which I think most people would think. So the nearest one is the Sagittarius dwarf elliptical. The second nearest is the Canis Major dwarf galaxy, which we probably can't see from this part of the world. And then the third nearest is the Large Magellanic Cloud. So the Small Magellanic Cloud is the fourth nearest. And it, as you can see in this picture, it contains several 100 million stars. And like its bigger brother, is an area of significant star forming. The blue areas are going to be the areas where you've got significant star forming going on. Stefan, do you want to pick up on that?
Yeah, sure. So one thing that I'll point out that not a lot of people know is that the Small Magellanic Cloud and the Large Magellanic Cloud, they're actually connected. But they're connected by a stream of neutral hydrogen gas. So it's not visible to our eyes, and there's not really many stars within this region. So it's not something that you can really photograph, at least I don't think. But yeah, there's a big tidal interaction between them. And they share this big common envelope of neutral hydrogen, which actually is an indication that these two Magellanic Clouds were gravitationally bound for quite a long time throughout their history. And yeah, one more thing about the Small Magellanic Cloud before we move on to the large, because the small, like you said, Steve, it really is overlooked a lot of the time. The Large Magellanic Cloud, obviously, given its name, it appears larger in the sky, and it contains a lot of big, bright nebulae, which we'll come to. But the Small Magellanic Cloud also contains a lot of really beautiful emission nebulae. And it's a fabulous area to image as an astro imager, particularly just on the skirt of the Small Magellanic Cloud. There's a number of emission nebulae, namely NGC 346, NGC 371. There's this sort of almost chain of emission nebulae, which are fantastic to image in hydrogen alpha and oxygen 3. So, you know, it's not often imaged. So if you're an astrophotographer, you know, give yourself a challenge and take some images in this region. I tried to a couple of years ago, but I just started imaging too late in the year and didn't get too far. But there's really some fantastic structure within there.
Now, Steve,
Oh, sorry, go on.
I am Steve. I have been asked to ask you why the Large Magellanic Cloud and Small Magellanic Cloud are boys.
Oh, what? Sorry?
Are boys. Why are they boys?
Why are they boys?
Yeah.
Oh, rather than girls?
Yeah. Why are they boys?
Did I refer
Linda
to...
has asked, why are they boys?
Oh, apologies. Apologies. Are they theys?
They're galaxy neutral, okay? They are not male, they are not female, they are just galaxies. All right? That is what they are. Now, I think,
moving on quickly from that one.
yeah, because you refer to them as big brother and little brother.
What's the current scientific thinking about the Magellanic Clouds being, whether they'll get gobbled up by the Milky Way, or have they already kind of had close encounters, or is there some current thinking on that? You know?
So it's again, I could look into this for next time that we cover these.
Apologies, I was trying to put you on the spot with that.
No, that's totally fine. So what I do know is that a lot of the structure, a lot of the reason that the Magellanic Clouds are structured the way they are is because of their interaction with the Milky Way. So you can see, particularly with the Large Magellanic Cloud pictured here, you can see this really obvious bar that's sort of stretching horizontally through it. And it's actually thought that the Large Magellanic Cloud used to be a small barred spiral galaxy, but through its interaction with the Small Magellanic Cloud and the tidal forces with the Milky Way, it's actually disturbed that structure a bit. And I last time I checked, I believe the consensus is that in the future, the Magellanic Clouds will eventually merge with the Milky Way and become a part of it. And yeah, I think that's true.
Yeah, I know that there's certainly, going back a few years, that was always what I sort of read and heard, was that they were going to get gobbled up. But then I thought I'd read somewhere that perhaps they may not do that, but I don't know. I think they probably will. In the same way that probably the Milky Way and the Andromeda Galaxy will eventually merge into a single mega galaxy.
Yeah, I think it just points out how lucky we are to live in this time where we can still see these dwarf galaxies. Who knows if we evolved in a different time period where they weren't in the sky, maybe we wouldn't have thought that dwarf galaxies or satellite galaxies were a thing. Yeah.
All right. I think we've gone off track. We'll get back on track now. That's my job. That's my job, is to keep you guys on task. And the task now is to look at this lovely 5-stacked image. Anne-Marie, how long are your images on this? I'm assuming they're 60-second again. Yeah, so they're 60-second images. So we've got 5 minutes of of the Eagle Nebula, but it's not 5 minutes worth of exposures here of NGC 7793. Now, while you guys are looking that up, we have a question from Mikhail. He wants to know, any thoughts, Stefan, towards the now defunct Kepler capturing SN2017 JGH going supernova reported recently in the media? Pretty awesome. Now, that is on the spot questioning. Stefan might have to get back to you on that one. I'm
glad he put Stefan on the spot with that one.
Well, look, I can say it is pretty awesome. I'll say that.
Do you know
Sorry?
Do you know? Have you been following it?
Absolutely, closely. Absolutely. No, not at all. I'll have to look into that. But look, any supernova, I'm a big fan of.
I know just a little bit about that one. Actually, it was as Mikhail mentioned, it was captured during the K2 mission for Kepler, which was finished in 2018. This was data from 2017 that someone's gone back and effectively they've gone back and looked back over the data and found that it went supernova. But of course, the Kepler's been long since abandoned as far as its mission goes. So that's sort of why it's a question of, well, now that we know something went supernova while we had the ability to see it, it's a question now of, will something be retasked to go back and look at it as it stands now? Because we're talking about, when we look at things that we've had before that we know have gone supernova, like Eta Carina and, the Shapley and things like that. This is something that's in our lifetime that we may be able to see changes. I reckon that would be absolutely fantastic. Let's push Hubble out to it. Let's push, if Kepler's still capable of anything, doing exactly the same thing it's already done and focusing specifically on that.
If we push Hubble out there, it might fall apart.
Well, again, you mean?
Again, yes, it might fall apart again. We've got it back again. Now, back to the task at hand, NGC 7793. Steve?
Do you remember earlier on I talked about I mentioned that we were going to be looking at a few galaxies in the Sculptor group, of which probably the most famous is NGC 253, which is the what's its common name?
Sculptor.
The Sculptor galaxy, or
Silver coin.
The Silver Coin, thank you. That was the name I was looking for. So this is another object in the Sculptor group, and including a couple of
It was there. It's disappeared. And while we wait for it to come back, Mikhail, don't be sorry, because that's half the fun of what we're doing here is putting these guys on the spot. It's good fun. Now, while we wait for Anne-Marie to get that lovely image back of that galaxy. Oh, Andy, you got in the way of Mona Lisa there. I was going to point out Mona Lisa in the background behind Andy. We're all over the shop tonight, but that's okay. We're all dealing with snap lockdown, so everyone's sort of just doing what we can to get by at the moment.
You can see me in tent too, in my my sort of webcam I've got.
Oh, yeah.
I've just put it.
That's Andy's setup, by the way. He's got a webcam. He's got his telescope out to the right-hand side there, and that's him over in the left in his tent.
It's pretty flaky, but it's working.
It is pretty flaky, but it does the job. Now, Anne-Marie, have you got that image back up again, or have we lost it? We've lost it again.
We've lost it. I accidentally moved the scope, so the last one had trails through it.
Oh, can we
So
just
I
pop
got
it
rid of
back
it now.
up?
I can't get it back up.
Get it back?
Well,
Oh,
I
no.
can restack it, but it's going to take some time.
That's okay.
Or we-
Restack
or
it.
we just-
Restack
okay.
it. We'll jump across to Caleb's got something going on over here. He's got a couple of galaxies in here, which I don't believe are even on our list tonight.
No, it's not. So
He's gone.
I
He's
guess
gone.
I'll
He's gone
be
AWOL.
fair.
He's full on A-teaming it at the moment. So this is NGC 5746 and 5740. He's
So 5746 down here.
Yep.
And 5740.
And I
There's
can
actually another
frantically
one
see-
which is. Sorry.
another one. I was going to say I can frantically see Steve and Stefan typing on their keyboards to get some information up for everybody.
Here's the framing. So there should be 1, 2, and 3. There should be a third one somewhere, but I can't see it. One,
That's
2,
okay. 2's better than 2 out of 3 ain't bad. Meatloaf said that.
That
so
one.
It's got to be true.
There it is.
Oh, there we go. It's there.
There's a third one.
Well, Meatloaf
So
likes
that's
it.
NGC 5746 and 5740. I can't. That's a UGC cut. Oh, actually, no, it gave me an NGC. MCG 0-38-2. I don't know what that
MCG, when
catalog
men
is.
kick goals.
Yeah. So
not this year.
NGC 5746 down here.
That's good. isn't it?
That's a barred spiral galaxy on the eastern part of the constellation of Virgo.
Yeah,
So it's
so-
95 million light years away. So this is now officially the furthest thing I've imaged intentionally that I
How
know
far
of.
away is it?
95 million light years away. The next best
95
was
million light years away. What was happening on Earth 95 million years ago?
good question.
One lot of dinosaurs.
There was a lot of dinosaurs
One lot of
about.
dinosaurs? Yes. So the light we are seeing now in this image started coming to us 95 million light years ago. 95 million years ago.
Do I see a nice dark line there in it?
Yes, you do. Yeah, there is a dark lane in there. There's a really just on the bottom side of it. Yeah, just
Yeah, it actually looks very similar to some Barrow Galaxy.
It does.
Yeah.
Yes. So for those looking at home, if you can see there, you can see the main bar. Yeah, and then there's that dark lane where the mouse cursor. If you want to move that mouse cursor through it again, so you got that dark
Right
lane
here.
there, and just under it is a little bit more of the galaxy. Now, what causes that, Steve?
Well, that dark line
Mm.
it's sort of dust areas, typically.
So if the dust wasn't there, it would look like just you'd have like a. Well, I'm going to let Stefan jump in here. I'm trying to explain something I can't explain.
No, it's yeah. So it's essentially
I've tried, Stefan,
areas
but
of.
I'm not you.
Don't worry, I'm not much anyway.
Oh,
So
you know a lot more than I do.
So yeah, those dust lanes are essentially cosmic dust, and what that is sort of cooler molecules. So when we think of like a nebula, for example, that nebula is comprised of take for example an emission nebula like the Orion Nebula. that emission nebula contains a lot of hydrogen and usually a lot of like oxygen, but these are all elemental or ionized gases. So it's ionized hydrogen, ionized oxygen. So they're not paired up, they're not binding to anything, they're not making molecules, but a lot of the sort of interstellar material, so the material between the stars, cools down enough that those atoms, those ionized atoms, can form and make molecules. So these are really sort of cooler areas of more, small molecules essentially. And when they clump together under their own gravity, they can reach a density where they start to block light from behind them. So that's what those big sort of dust bands are in those galaxies, where a lot of smaller
exactly
molecules
what
have
I
sort
was
of
gonna
clumped
say,
together and
Steve.
blocked light from behind.
That you took the words right out of my mouth. That's exactly what I was going to say. I don't know how you knew that.
I was just looking up the statistics on the two galaxies that you can see there, the bigger one and the smaller one. They're actually a similar distance away from us. So just looking at them, you say, oh no, that the one at the top is a lot further away, but it's actually not. It's just a smaller galaxy.
Oh, fuck's sake.
Our faint fuzzy. Anne-Marie keeps moving the scope after she's done her images.
No, I didn't. I didn't.
With an open mic.
With an open mic. With an open
did
mic.
I-
Yep.
Sorry, I just dropped it.
You didn't
Sorry,
swear,
guys.
did you, Anne-Marie? I can't.
I
mute
did.
swearing. Oh no! Facebook
Sorry.
and YouTube are going to not like that. No, it's all
All
right.
right.
Have
I'm
you got
moving on
your-
to the next target. Look, it's on the screen.
No,
But
before you do, we've got to come back to this. Ignore the lines moving through. That's Anne-Marie accidentally moving off the target, but this is 6 minutes.
7793.
Yeah, 6 minutes of the Galaxy 7793 that we were meant to talk about earlier. We finally got there. Once we've spoken about it, we do have a question from one of our viewers, which I will jump to after you guys have had a chat about this object. And silence.
Well, as I was sort of talking about a few minutes ago, this is one of the galaxies in the Sculptor group. So remember, we were sort of waiting for them to sort of come up over in the east, and they've come up a little bit higher now. So this group of galaxies in the constellation Sculptor are reasonably close to us. This galaxy, which is NGC 7793, is a face-on spiral, as you can see, is 12 million light years away. Apparently, it's loosely bound. So I think this is gravitationally. The Sculptor group is the group is loosely bound gravitationally to NGC 253, which is the galaxy I was having a problem with the name of, which is the Silver Coin Galaxy or the Sculptor Galaxy. Sorry, Stefan, I cut you off there.
No, that's all right. So I just wanted to point out that this is another sort of almost face-on spiral galaxy, but it's an unusual type of spiral galaxy. Unlike the grand design spiral galaxies that we were looking at before, where you can really distinguish all of those individual arms, with this galaxy, you can tell it's a spiral galaxy, right? You can see that it's sort of like that whirlpool spiral structure, but no matter how close you look, you can't really count how many arms are in this galaxy. That's because it's not a grand design spiral galaxy. It's what's called a flocculent spiral galaxy. And that word flocculent means fluffy. So because essentially the arms do look sort of fluffy. It does have that spiral structure, but you can't really distinguish any specific arms. Like most flocculent galaxies, it's a galaxy that's really rich in star formation. Because it has no distinguished arms, all of that material in its galactic disk is sort of churning up, and it's basically giving birth to a lot of new stars very, very quickly. And because of this, there have been a number of supernovae observed in this galaxy, with one of the more recent ones observed in 2008. And one really interesting object within this particular galaxy that I found out about today, I'd never heard of this type of object before. It's called a microquasar. So if you haven't heard of a quasar before, the name quasar comes from quasi-stellar radio source. So long before, or not that long ago, I guess, I think within certainly the last century, astronomers were making measurements of objects out in space, and they found that some objects put out a particularly high amount of radio emission. But these objects looked just like stars. They were pinpoints, just like stars, but they put out a lot of radio waves, and hence the name quasi-stellar radio source. Now, of course, we know that these quasars, these quasi-stellar radio sources, are actually galaxies very, very early, very, very far away from very, very early on in the universe. Very, very active galaxies with massive black holes eating up a lot of material, shooting out a lot of high energy radiation. Now, this particular galaxy has, as I mentioned, a microquasar. So it isn't, it doesn't have, well, I don't know if it may have a supermassive black hole at the center of this galaxy, but that's not what I'm talking about here. In fact, there's been a smaller black hole observed, around 15 stellar masses, in one of the outer arms of this galaxy. And this object is what we call a microquasar because it's actively feeding on a large star, around 20 solar masses, that's in a binary system with this black hole. So this massive star, 20 solar masses, orbits the black hole with a period of around 64 days. And some measurements have suggested that the black hole is actually stripping away material from the star at rates that are 10 times what we thought was previously possible. So either there's some uncertainty in the measurement, or we don't fully understand the interactions between black holes of this size and their binary stars. But yeah, just one particularly interesting object which I hadn't heard of before.
Now, I believe Lee is trying to open up Space Engine. He's got a very good example of a microquasar that he's going to try and show us.
Yeah, just got to wait for it to open up. I hadn't quite prepared by opening it up.
We caught you off. We caught you off guard.
Yep.
So we'll jump back to Caleb's little view here. Andy, unfortunately, is clouded out. I think Anne-Marie's jumping across to the next object that she's got. So while we wait for that to happen, and while we wait for Lee to get it going, Andy, Caleb, if you can leave that up for a second. We had a question about dust lanes. And Ian wants to know, is the dust part of the galaxy or something much closer?
Certainly in this case, and most cases, the dust lanes that we see when we look at galaxies are part of that galaxy. It's dust and gas that's accumulated within the plane of that galaxy. It can be the case, though, that there is dust in between our galaxy and other galaxies that we're observing. And one particularly notable example of that, which springs to my mind, is the example in the Northern Hemisphere. There's a pair of galaxies. One's called Bode's Galaxy, and the other is called the Cigar Galaxy. And when us astrophotographers take images of those galaxies, if we image for long enough, we can actually make out some gas and dust that is obscuring those galaxies. And that gas and dust is actually gas and dust that's sort of in the halo of our own Milky Way, in between our galaxy and that galaxy. And it's a really, really beautiful thing to image. It's called the Integrated Flux Nebula, because that nebulosity, that gas and dust, isn't lit up by any local source, any star that's embedded within it, but instead it's lit up by the integrated light of the entire Milky Way galaxy reflecting off of it. But yeah, to bring it back to your question, whenever you see a dust lane in a galaxy like the one on screen, for certain, that dust is within that galaxy, the plane of that galaxy.
All right, now we've got that. There we go. We're talking about quasars, was it before?
Micro quasar.
Micro quasars. There we go. That'd be a micro quasar around a black hole.
Yep.
So there we go.
We actually go
Can you
forward.
change angles on that for us?
It's a little bit hard, actually, for some reason. Whoa, there we go.
There we go.
The thing is, it's actually so bright that I need to. Oh, hang on. Here we go. That's better.
That's better. Can we pan around while we're looking at this? Is that possible?
Yeah, we'll go.
So this is Space Engine, which we've I think we used last time.
Oh, nope, not that one.
And yes, Tim, it is. It is indeed Shades of Interstellar.
Yeah.
Just make sure you have a fire extinguisher next to your graphics card.
Yeah.
That's how we deal with it, isn't it?
Yep.
On all our sales.
Ooh. So you can see that's actually, I think that's, in terms of how it's rendering this, that's basically running in real time as opposed to being sped up. You see a lot of objects when we go and look at other objects. Like you see this massive sun in the background here. If I speed time right up, you then see activity from that. Whereas with the micro quasar, it's actually significantly fast, and that's orbiting. They're probably orbiting each other, but you have to speed time up significantly to see any activity for the sun, but you don't have to for this because it's just whatever it's doing is so fast.
That's right. So this is an example of what we were talking about last time, angular momentum. So when something with a lot of mass brings that mass in closer to its... Yeah. I mean, it's a really fascinating thing because a lot of... objects out in the universe are the most extreme examples of this. So as an example, imagine a figure skater spinning around with her arms out, and as she pulls she has angular momentum, right? Angular momentum is just momentum in a rotational frame. As she pulls her arms closer to her chest, that angular momentum stays the same, but the center of mass is closer to the point at which she's rotating, so she spins faster and faster and faster. That's the exact same thing with objects out there in the universe. Take, for example, a star a little bit bigger than our own sun. When that star reaches the end of its life, it'll start collapsing in on itself. And if it's large enough, it'll collapse into a neutron star. And all of that mass, if it was rotating, which most celestial bodies do, as it collapses down and down and down, it'll rotate faster and faster and faster, to the point where a lot of neutron stars that we know out there in the universe are what we call millisecond neutron stars, or millisecond pulsars, because they're objects, as big as a city, 20 kilometers in diameter, but they rotate with a period of less than a millisecond, so thousands of times per second. And black holes are even more extreme examples of these, where neutron stars will then even collapse further and further and further, and the black holes will have some angular momentum that's just ridiculous. Now, what we're seeing in this simulation is a lot of material that's accreting around the black hole, and like we pointed out, this is an accurate sort of time scale. material, as it falls into a black hole, if it's rotating around, it'll fall faster and faster and faster, to the point where most matter will reach almost light speed velocities as it reaches the black hole. And in doing so, this generates a lot of energy, which you see these collimated beams spewing out perpendicular to the rotation of the disk.
That's a very good position to put that in, Lee. That shows it really well.
Well, you can see the lensing as well.
Yeah, the bolt. Yeah, yep, absolutely.
Yeah.
And just a shout out to the person who wrote this program. This entire program, this game, this simulation, written by one guy, and it's available on his website, Space Engine. It's also available on Steam. It's only like $20. If you're interested in space and you want to actually visit these things, check it out. It's definitely worth it.
Yeah.
And this dude definitely has earned his $20.
$20.
Or a bit more if you buy the professional version.
a bit more of you, yes. If you buy, we've got. I just want to say this relates back to Anne-Marie's image earlier. It wasn't Starlink; it was Anne-Marie moving her scope mid-shot. But hello, Astronomical Society of Tasmania, and thank you for joining us tonight as well. So now, have we got any other galaxies that we can share, guys? I think we're waiting for some to rise.
Yes, well, we've got some over to the east now. I'm just I was waiting for the cloud to go, and it has not. It did, and then I got a plate solve, but then I've got nothing.
Okay, so we've got some cloud coming in. Caleb's got Caleb's got something up on the screen here. What are we looking at, Caleb?
That's Barnard's Galaxy.
Barnard's Galaxy, which we've been trying to image tonight, but it's in the wrong spot at the moment for Anne-Marie, and there's clouds in the way for Lee. So we're going to use a pre-imaged version. Apologies for that. We have had some great success tonight, but this one has eluded us at the moment. So if the boys want to, I am Steve and Rocket, if you want to have,
That's me. It's all right.
That's you. If you guys want to have a chat about Barnard's Galaxy there, this is an image that, so before you jump onto it, Caleb, what's the go with the exposures on this one?
So that's, I'm just trying to remember, 100 and, let me get my document open. It is about 3.5 hours.
3.5 hours, yep.
1 second, just 294 MC, that's Barnard's Galaxy. I've got a write-up document for everything. Oh, there it is. So 3 hours and 40 minutes. 110 subs of 2 minutes each. And that's actually with my with the scope I used tonight, with the camera I used tonight, but a different version. So the non-cooled version of that particular chip. So yeah, it wasn't fun when I did it because the noise is ridiculous. But yeah, this is Barnard's Galaxy. So NGC 6822. So 3 hours and 40 minutes of exposure. No filter. From a Bottle 6 zone, so urban-ish sky. So it is a very challenging target to do. I'm just pulling out one of the single sub. Gonna do a quick debayer so I can show you guys what one sub looks like versus 110. And it will be green, that's normal. And then I'll do a quick STF.
Look at this. This is processing on the fly.
So that's 2 minutes. You can just about to see the core.
Yep. You just make a little bit of it out there, a little hazy patch.
Yeah, if I make a stretch it, you can just about to see. It's not good to do that, but I'll just undo that. If I relink it, You can just about to see if I stretch it really hard,
Yeah.
right there. And this is 110 subs with a lot of processing.
Neil says you won't be Insta famous if you don't use a filter.
Well, I don't have a filter because broadband, and I don't have a broadband COS, so I see like suppression or Optolong. What's it called? L Pro. I don't have that. Normally I use a monochrome camera, but it is back for servicing. So obviously, if I use my monochrome camera, I will be using some LRGB filters. And actually, Barnard's Galaxy is one of the objects that I want to redo with my mono camera, but I don't think it will happen this year.
This is one of those objects that you just wouldn't bother with visually through a telescope because it's a big object. It's about 17 arc minutes across.
So it's just under the side, like maybe half of the full moon, I guess I would say. So, but the surface brightness is very dim.
Yeah, its visual magnitude is 9.34, which for an object that big is not very bright at all. So very hard to see visually. It's one of the family. It's part of our local group with the Milky Way and Andromeda and some of the other local galaxies. It's only 1.6 million light years away, and it's classified as a dwarf irregular galaxy. In the sky, it's up high at the moment in getting higher in Sagittarius. And as you can sort of see, it sort of kind of has a similar structure to what you would see with the Magellanic Clouds, particularly the small Magellanic Cloud.
To give you an idea of how big it is, roughly, it's been estimated to contain around 10 million stars, which sounds like a lot, but that's about the same number of stars in the Omega Centauri globular cluster, which is a globular cluster in as a part of our galaxy. It's still quite a significant number of stars, but if we're calling that a galaxy, I think we should call Omega Centauri a galaxy too. Don't be mean to Omega Centauri. But
galaxy.
Yes. So it was discovered in 1884 by an American astronomer called E. Barnard, hence the name. And one interesting historical fact about Barnard's galaxy is that it was actually the first galaxy beyond the Magellanic Clouds to have its distance measured. And this was done by Edwin Hubble in the 1920s. And because of that, Barnard's galaxy was actually one of the first pieces of strong evidence that our Milky Way galaxy wasn't the entire universe, that there were different entities, different galaxies outside of our own. So I guess that makes it somewhat historically significant. The way
Omega Centauri.
Yeah, beautiful. So
Did you say there's about the same amount of stars in Omega Centauri to Barnard's galaxy?
Yeah. Both contain approximately 10 million stars.
Isn't that interesting? What does that say about Omega Centauri?
Sorry, say again?
What does that say about Omega? The fact that these both have similar amounts of stars in them.
Yeah. So as we've spoken about Omega Centauri before, it is thought that Omega Centauri is actually the core of a galaxy that was cannibalized by our own Milky Way. But yeah,
we're a hungry galaxy. Can you blame us?
Indeed.
Now, I think we've got some more live stack galaxies to bring you. Andy had one up, but I can't see it there anymore. Andy, can you bring that one back for us? And no, he's saying no. We'll jump across to Anne Marie's then. And I'm not sure what happened to Andy. He had something going for a while. Anne Marie's got NGC 1313 at the moment. Now, that is on our list.
It is on this.
It is on our list. So take it away, guys. We've got 3, I'm assuming they're 60-second images. So this is 3 60-second images.
No,
Anne-Marie?
the first 2 were 2 minutes, and now they're doing 60-second ones.
Okay, so we've got 5 minutes worth of images.
Yep.
And
it's really pretty in colour.
It is. Before we push on any further, I just want to say thank you to Caleb, who has come along all the way from the land of Queen's Sunshine in Queensland there, who's now he's done. He's out. He can't get any more for us, so he's off. Thank you, Caleb, for joining us tonight.
Caleb.
No worries.
And,
It's a pleasure.
hopefully, at least you are out of lockdown tomorrow. Fingers crossed.
Yeah, fingers crossed. 4 p.m. I think 4 p.m. or something. I don't know.
Well, let's hope.
Not
let's
counting
hope.
the hours.
Yeah, he's not counting at
I'm
all.
not going out at 4:01. Don't worry. Right.
And with that, thanks, Caleb. Bye. No,
No worries. Take care.
we'll continue on with the Galaxies, and thank you very much, Caleb, for joining us tonight. Now, we got 5 minutes worth of images here on NGC 1313. Stefan, Steve, take it away, guys.
Guess I can start this one off. So as you can see, it's definitely a bit of an irregular looking galaxy. It's not a spiral galaxy. It's it is somewhat a spiral galaxy, but it's not a grand design spiral galaxy. It doesn't have these sort of obvious numerous arms. It is, though, a barred galaxy. You can definitely make that out, sort of going from the bottom left to the top right, that sort of faint bar. It's around 13 to 15 million light years away, and it's around 50,000 light years in diameter, so somewhere below half of the Milky Way's size. And it also lies within the Virgo supercluster. But as you can see, it appears very, very ragged. There are sort of these patches where it's brighter near the top and the bottom, but it's very, very uneven. And all of this is clear evidence that it's undergone, a bit of a chaotic history, likely a galactic collision somewhere in its past. But now we actually think that it's a field galaxy, so another galaxy that's isolated off by itself in intergalactic space, not really gravitationally bound to any particular cluster, which suggests that if it did undergo some collision, it's since absorbed the galaxy that it's collided with. And finally, there have been some detections of very, very high energy X-ray sources in this galaxy, which we think are indicative of some intermediate mass black holes.
Anyone that's interested in where this is, it's in the constellation Reticulum, which is one of the small constellations heading towards the South Celestial Pole. It's actually quite close to the Large Magellanic Cloud as well, reasonably close.
How close is reasonably close?
A few degrees, I think we'll say.
So it's not far off then. Easy to hop to manually when you're visually looking at this?
No, this is, what it's like with down as you get towards the South Celestial Pole, the number of bright stars of reference stars starts to diminish. It's not too far off the top of Reticulum, which is sort of like a diamond shape, and it sits just off the top of Beta Reticulum, the second brightest star.
So you can make your way there if you need to.
Yeah, it's so visually. I think Stefan, it's magnitude 9.18. So it's not the brightest, but it should be well within the reach of a 10-inch scope in a dark sky.
Is this about what it would look like through, say, the 40-inch?
I guess so.
Fairly, maybe a bit fainter.
Yeah, it's so magnitude 9.18. Apparent size is 11 by 9 arc minutes. So it's because it's a fairly close object. It's only what did Stefan say? Is it about 14 million light years away, something like that?
I can see.
So it wouldn't be the easiest.
I can see in there there's a faint fuzzy down on the right-hand side there, probably about 4 o'clock. Sort of 4:30-ish on the, if we're doing clockwork there, just down in the bottom corner. Yeah, a little faint fuzzy there. Do we?
I wouldn't even say faint.
Do we know what that is?
So I think that's the A component of. So there's NGC 1313, and then there's 1313A. I think that's the A component. So I'm assuming that small galaxy off to the right there is gravitationally attached to its big brother. I'm assuming.
I can hear someone clicking, trying to work out what that one is.
I'm pretty sure. Well, I've got it in Sky Safari, so let's have a look. How far away? Oh no, I'm completely wrong. So sorry. Unwind. So the A component has got nothing to do with with 1313. Do you remember I was saying that it's, the 1313 is fairly close, whereas the 1313A is actually 250 million light years away.
Now, we've got a comment here from the boss, our Deep Sky Section Director. It looks a little bit better than that in the 40-inch, a little bit more structure. So there we go. If you're not an ASV member and you'd love to see this particular galaxy with your own eyes through a telescope, you can see it looking better than Anne-Marie's amazing images through our 40-inch telescope. But you've got to be an ASV member to do that. So join now. Now you're showing off, Anne-Marie.
I mean, really? Can you see it better than that?
No, I don't think we can see it better than that. Can I ask how many hours is that?
I'd have to go and have a look. Hang on.
Anne-Marie's just mic dropped to Paul Gardner.
Oh, did she what? Mic dropping big time.
So the A component is up at the top left.
Yeah, it's up in the top right, top left-hand corner now. About 10 o'clock-ish.
You can actually see the sort of spiral structure in that 1313A, and at 250 million light years away, that's pretty damn good, really, isn't it?
It's a very impressive image. I'm curious. Do you know what did you?
Yeah, I'm looking.
You're looking? Okay, I'm curious to know.
8 hours and 32 minutes.
Okay, so you could sit around an image for 8 hours and 32 minutes, or you could look through at the ASV's 40-inch and see that with your eyes, not that good, but better than the other one. Now, I'm going to be cheeky and say I'll go with the visual. No, but look, from a longevity point of view, so I guess the bonus is you can see it visually while you're imaging up at the dark sky site, because we have the astrophotography field. So Anne-Marie could set her gear up at our dark sky site and image this galaxy for 8 hours. And while it's doing that, she can come and have a look and see it visually like this.
I could.
Yeah.
Challenge.
2 birds, 1 stone. How's that?
And just stand off to the side, I bet, saying, I reckon my stacking's probably going to be better than this.
The stacking would be better, but it is quite a sight to visually see a galaxy with your own eyes. like live looking through a telescope. It is something else. I mean, this is live as we can bring you without you physically being at our dark sky site. So this is pretty cool. And this is essentially, from a deep sky section point of view, this is essentially what we do. We look at objects like this, and this is sort of what we see visually with our eyes through the large telescope that we've got up there. And it's awe-inspiring to be able to see another galaxy through a telescope with your own eyes that's this far away. It's quite something. And then in the added bonus of what Anne-Marie does and what Lee does and what Andy and Caleb do with their imaging, to spend hours imaging something and then process it and see that extra detail of something you've visually seen. It makes it all worthwhile. It makes it so much more enjoyable.
The little component there, the
little guy on the right hand side there.
Yep. The magnitude of that is 14.72. So that's beyond the capability of your average size telescope. So a 10 or a 12-inch scope can see down to about magnitude 14 in a very dark sky, but the 40-inch should easily be able to see that.
I dare say that Paul will put another comment up and tell us how far.
Perhaps that's a little challenge
the 40-inch can see.
Yeah.
I know it's a lot more than that, but I'm sure he'll tell us. And if he does, we'll jump on that. I think we're going to jump across to Andy now. Andy has got NGC 6774. Now, Andy, how long have you been imaging this one for tonight? This is currently happening now.
Yeah, it's happening now. I've got 12 minutes so far, but I've just had to cancel it because clouds have just gone over again. But yeah, I've just stopped it at 12 minutes. So I'm just waiting for clouds to go past and I'll start it off again. But this is a Coolbill catalogue, C101 as well, which was named by Patrick Moore. And rather than using the M, like there's Messier catalogue, like he wanted to call it the Moore catalogue. He's got his own galaxies and objects, a fair few in the southern hemisphere. He had to use his middle name, so it's a C catalogue. But that's about as far as I know about this galaxy. Yeah, it's stopping on 13 stacks at the moment. Just waiting for the clouds to clear, of course. I'll just zoom in.
So this is another example of a spiral galaxy. This is what's called an intermediate spiral galaxy. Again, because it has a very, intermediate-sized bar in its galactic nucleus. It's located in the constellation Parvo, or the Peacock, and it's around 30 million light years away. Like many of these galaxies, it's also a part of the Virgo supercluster. And this galaxy is sort of known to astronomers to be somewhat like the Milky Way's bigger brother, almost. It's a similar structure to the Milky Way with that sort of intermediate bar and sort of loosely formed spiral arms, but it's a little bit bigger. It's around 200,000 light years in diameter, as opposed to the Milky Way's 100 to 150,000 light years. The spiral arms are not exactly super tight. It's slightly flocculent, and actually you can't quite make it out in this image, but if you were to stack for multiple hours, what you would see is that one of these spiral arms actually extends all the way out to a dwarf galaxy that's a satellite of it. Again, almost reminiscent of the Large Magellanic Cloud. But yeah, there's this really obvious stream coming off of one of the spiral arms into the dwarf galaxy.
I think it's that, Stefan. I think it's the sort of 20 past as we're looking at. If you follow the outer spiral arm, you can see at the end, at the tip there, at about 20 past, it starts to brighten a little bit. I think that's where the other component is. Yeah. Come back. Yeah. There. Yeah.
Yeah, I think you might be right. Yeah.
I'm just looking at the photograph of it on my iPad, and that seems to be where that component is.
How far
Beautiful.
away is this one again?
Yeah, 12 minutes.
30 million light-years.
12 million light years. What's something?
Yeah, 12 minutes is just doesn't do justice to this. You'd need a good hour at least to start seeing some stuff. 3 or 4 hours would be perfect.
On that, Anne-Marie has shared a completed image of it.
Unless you got Anne-Marie's here.
Yeah, how many hours have you spent on this image of the same galaxy? Whoop.
Hang on,
Wow.
I'll have to have a look.
Just got to have a look. So this is your completed image of NGC 6774. And
Yeah, I did this one just recently.
Yeah, if you look up towards sort of 10 o'clock, you can see that galaxy you were talking about, Stephen. You can see it there. The little fuzzy there. So that's about
This is just
where,
under 3.5 hours.
3.5 hours. So this is 3.5 hours of imaging of the same object we're looking at over here. So this is the live version. Just assume that it's 180 degrees rotated the other way.
I think it is. I'm kind of thinking.
No, it absolutely is. It absolutely is rotated 180 degrees. I can tell because you can see the 3 star. There's 3 stars in a row there underneath that bright one up in the top left.
Oh yes.
And then when you jump across here, you can see those same 3 stars down in the bottom corner there. So yeah, it's flipped around, but that's the same object. One's live that we're looking at now, which is this one here. And the other one is 3 hours worth of data processed. So you can see why the astrophotography guys and gals, or the astrophotography people, sorry, Anne-Marie, why they spend so much time imaging objects. This is the end result of something that Andy is streaming live for us now through his equipment. So his equipment shows us a great deal of what we're looking at, what we're trying to see. And Anne-Marie's image, well, where'd we go? We lost your other image there, Anne-Marie. We'll wait for that one to come back if I can. It's not going to come back, is it? Anne-Marie's image that we saw before shows why they spend so long imaging the objects that they image and the detail that you get out of it.
From a visual perspective, there are two really good objects in Parvo, the peacock. This galaxy is one of them, and there's a really good globular cluster as well, which is NGC 6752. Those are the 2 objects that you would typically sort of go to visually in Parvo.
I'm really enjoying just seeing the difference in these two, you know, the live version here and then the processed 3-hour image here. So this shows you can see all those blue stars in there, all those blue sections. I don't know if they're stars. Are they stars, Steve? They look like they might be.
Mm-hmm. Yeah.
These little blue.
They're star-forming areas, yeah.
Star-forming areas, and then you look here in this one, and you can't quite see.
They're actually stars, so they're the young blue stars. Is it the O's and the A's?
And then you can't quite see those in this live image. It's quite interesting how that all happens. Now, just quickly, Paul says, "Hi, Dad," and then Paul's dad says, "Hi, Paul." Yeah, how good is that? Father and son watching the stream at the moment. I love it. I love it.
And you even see the heritage there with a little shamrock in the.
You can indeed. Yep.
Yes.
what a community we've got.
We have.
To be
we
sure,
have
to be
indeed.
sure.
Now, Lee, have you got anything you can share with us, galaxy-wise, or I think we might
No.
almost be at. It might be at
Just
the end,
my,
unless Anne Marie's got something else she can jump onto for us. We might well be coming to a close.
Yeah, at the moment I've only got my
No.
All Sky camera showing how cloudy it is.
I,
There we go.
I've got one up there, Mark.
Okay, well, that's Ringwood at the moment for everyone. This is live, and that is Ringwood's night sky right now. Nothing but clouds. Well, patchy
Oh.
clouds.
Yeah.
I've still got
I've got
plenty
it-
to
well,
go.
Well, Anne-Marie, you are our saviour, so take it away. What are we on at the moment?
7424.
7424.
The grand design.
Well,
The
well
grand
done, Anne-Marie.
design.
Yeah, I was going to ask if anyone, because we were talking about, well, Stefan talked about that flocculent galaxy earlier on, and this is the opposite. Over to you, Stefan.
I like that. Hey, Stephen's talked about this before. Over to you, Stefan.
Did you see that bus coming?
Not at all.
It was like a baseball bat to the back of the head, that one was, wasn't it?
I was just in the midst of looking up what that star is. I'll get there in a second. Give me 1 second.
It's the Grand Design galaxy, so it's the opposite of your flocculent galaxy that we looked at earlier on. This has wonderful spiral structure about it, which is why it's called the Grand Design, because it's the grand design of spiral galaxies.
Is that star not Fomalhaut? I think it's pretty close to there.
I've just looked it up, and all I can get is HD 216742, just some relatively
Alright,
bright
so
star, but I don't know.
Can I just jump in
Formal
for a second? Neil, I keep hearing the same thing. Every time they say flocculent, I hear flatulent as well. So you're not the only one.
That's it depends on what he's been eating, I suppose. But
Yeah, Stefan, I think that is HD 216742.
Yeah, that's all I've got for that one.
Can I,
I guess we could.
Can I just quickly say thank you to another new Twitch follower? We have another new Twitch follower, so that's great news. We're now up to 15 Twitch followers. So anyone who's got Twitch, we also stream on Twitch as well as Facebook and YouTube. Back to you, Stefan.
Yeah, so coming back to the galaxy finally. So as Steve mentioned, this is the opposite of a flocculent galaxy, where flocculent, fluffy, not really got any defined spiral structure. This one is a grand design spiral galaxy. I believe its actual common name is the Grand Design Galaxy.
Yeah.
And you can really see where that name comes from. If we zoom into the image somehow, if we can do that, what you'll start to notice is that those spiral arms are really well defined. There are areas where, they're very high in density and areas where they're not, where they're low in density. You can really see those arms sort of jumping out at you. So this particular galaxy is in the constellation of Groot, which is the crane. Not a constellation I know a lot about. I know there's a nice grouping of galaxies nearby, the Groot Quartet, I think it's called. Yeah. But back to this galaxy, it's around 38 million light years away. And it's similar in size to the Milky Way, with a diameter of around 100,000 light years. Being face on, it's a fairly low surface brightness galaxy. So it's relatively hard to see visually. And as you can see, imaging, you can definitely pick it out, but you do need favorable equipment and conditions. Like the Milky Way, it's also got a large distinction between young blue hot stars in the outer arms and older, sort of larger, redder, yellow, hot, cooler stars in the core in that bar. And Like some of the other galaxies that we've spoken about, it's suspected that this one is another field galaxy, and it's fairly typical that field galaxies, so those that are isolated, are able to generate or are able to generate this sort of grand design spiral because they aren't sort of interacting with anything that's messing up their spiral structure. And just one thing more generally about spiral galaxies, I guess I can talk about, is the arms themselves, the spiral arms. It's tempting to think of these as physical objects, like your arms that are sort of connected and spiral around as you move around in a circle. But actually, the spiral arms that we see in galaxies are not physical objects. They are waves. They're waves of density sort of moving through the galaxy itself. It's kind of difficult to describe, but if you look up on YouTube, you'll be able to see some really elegant simulations that can help you understand what these density waves really look like.
We've got a couple of questions, guys, but before I get to those two questions, Sean, you did see no, it was an eagle, wasn't it, Anne-Marie, not a hawk?
Falcon.
Falcon. There we go.
It's a falcon, yeah.
Falcon,
Yeah.
not a hawk. You don't need to
No.
go to bed, Sean.
No,
Now-
it's a falcon.
Falcon, there we go. Yeah. What sort of galaxy is this again? What are we looking at? What type of galaxy are we looking at?
It's called a grand design spiral galaxy.
There we go. And we have another question. With Anne-Marie's previous image, which kind of relates to this as well, the blue areas are globular clusters. Are the blue areas globular clusters? Considering we're looking at a galaxy, can single stars be identified in other galaxies?
So the temperature of a star tells us a little bit. So the color of a star, tells us a little bit about their temperature and also their age. So how the color and the temperature of a star is related is described quite nicely by a famous diagram in astrophysics called the Hertzsprung-Russell diagram.
Oh, the Hertzsprung-Russell diagram.
That's another name for it, I guess.
So,
and
it's like,
yeah, another good thing about that diagram is that it shows you the typical path of a typical star, how it will evolve throughout its life, starting off as a sort of any type of star, and how it'll evolve and grow larger and larger and cooler. So to address the question, blue stars typically come about. Blue stars are typically very, very young, very, very high mass, very high energy, hot stars. And these young, hot stars typically form where there's a lot of star formation happening. And that typically is in the spiral arms of galaxies, where a lot of material is colliding together and aggregating together under gravity and forming these new stars. Blue stars like this, these blue giants, they're typically not very long-lived. They're only around for a few millions of years, and before they, go supernova or however they end their lives. But the yellower regions towards the core, these are the more mature, more old stars that have, they're smaller, so they live longer. But as they're reaching their older age, they sort of swell up and become these red giant stars and sort of cool off. So within Anne-Marie's image, it's not likely that we're seeing individual globular clusters, but those blue regions are regions where there's a lot of young, hot blue stars forming. And as to the second part of your question, can single stars be identified in other galaxies? It sort of depends. In very, very far away galaxies like this, there are I don't even think the Hubble Space Telescope would have resolution to be able to resolve individual stars. We just see the sort of aggregate glow from all of the stars together. When we're looking at very nearby galaxies, like the Andromeda Galaxy, we are able to resolve individual stars. And there are some really amazing Hubble images of the Andromeda Galaxy where you can see all of those individual stars, and it's just absolutely fantastic.
Brilliant answer. Oh, I'm being picked on at the moment in the comments. I don't know if this is a compliment or not, but Neil says I'm very hot. Blue Stars are very hot like me. I'm not that young, Neil. But thank you for the compliment. You know, I know you think I'm hot. It's okay.
And he might be colourblind too. You're green at the moment.
I'm green at the moment. Hey, my t-shirt matches my hair as well. Is Mark flocculent? It depends on what I eat as to whether I'm flocculent or not.
Hey, Mark, you know we had Fluffy the Galaxy earlier on. Well,
yes.
meet Fluffy the Dalek.
Fluffy the Dalek.
What do you think of that?
We have descended into chaos.
He's an England supporter, of course.
Well, no, it's not coming home. It's coming Rome. Now, I think we were trying to get NGC 55, but I think Anne-Marie's got Cloud at the moment. Is that right, Anne-Marie? You got Cloud, or?
No, it's come back.
It's come back. Can I share your screen again then? Is it ready to roll?
The first shot wasn't very good, but the second one's just come through and it doesn't look too bad. So, yep, I haven't started watching it, so go. Yep.
All right, so we're on. Can we make that? Oh, there we go. Much bigger.
Yeah.
So we're sort of jumping back to a much earlier object on our list, NGC 55. I don't know if you can see that. It's fairly faint at the moment, but it will start to get clearer.
It will get better.
Yep.
This is probably the second brightest galaxy in the Sculptor group after NGC 253. And this is another. Oh, there we go. That's a lot better now that
That's
it's
much better.
So,
I had Cloud.
yeah. So pretty close. It's about 7 million light years away, 6.97 million light years away. It's another huge object to look at visually. So it's about 30 arc minutes across, so half a degree. Edge-on barred spiral galaxy with some rather unusual sort of structure in it as well, which I might leave that to Stefan to talk about if he can do. Stefan, can you?
No pressure, Stefan. No pressure at all.
Yeah.
I think we may have talked about this one in a previous session.
I think we may have. But anyway, so this is another, edge-on galaxy. And it's what we call an irregular barred spiral galaxy. And we call it irregular because it has an irregular morphology. It has a bit of an irregular shape. As you can see, we can make out that it would have a bar, and it has some spiral structure, but it's definitely been disturbed at some point in its past. And it's actually thought that NGC 55 has a similar morphology, a similar structure to the Large Magellanic Cloud. However, in this case, we're seeing it edge-on instead of face-on. So if you picture back to when we looked at the Large Magellanic Cloud, we could definitely make out that bar and then just sort of some weird straggly bits coming off toward the top. This is sort of similar to what we're seeing here, just edge-on instead. And as a result of it being an irregular galaxy, having undergone some kind of interaction in its past, it's now undergoing a lot of star formation. So this is very typical. When something interacts with a galaxy, it mixes everything up. All of the interstellar gas and dust that's within this galaxy gets smushed together in some areas, and that gives rise to a lot of stars. So this is a fabulous galaxy. So usually when we image galaxies as astrophotographers, we image in broadband. So we image with a one-shot color or with red, green, and blue filters. But some galaxies really benefit from using a hydrogen alpha filter to pull out some of the hydrogen emission that's within these galaxies that are resulting from those emission nebulae embedded within those galaxies. And this is another example of one of those. If you use a hydrogen alpha filter to enhance the emission coming from those regions, you'll see these sort of pink structures, the emission nebulae embedded within it. And you can definitely make it out in this image here, this sort of string of faint pink blobs all through the center. Those are big star-forming regions, like emission nebulae that we've looked at in some of our past streams.
Now, Anne-Marie, can we bring back the image you've got, the live stack image? Is that possible? Yep. Okay, so the reason I say that, because Sean's asking, was that image live? Sean, this image is live. This is 5 minutes, Anne-Marie? Or was the first one a couple of minutes again, or?
You've stacked 6.
Sorry, 6 minutes now.
6 minutes. So this is 6 minutes. So Anne-Marie's been imaging this for the last 6 minutes. So this is, aside from physically putting your eye to an eyepiece of a telescope, this is as live as we can bring a galaxy to you. This is 6 minutes from the last 6 minutes, well, maybe a little bit longer, of Anne-Marie's telescope taking 1 minute exposures of this galaxy. It doesn't really get much more live than this, does it, Steve, other than putting your eye to it?
No, I was thinking that the view that we're seeing at the moment is pretty similar to what we would see probably through the 40.
The good old 40.
Yeah. So certainly there's more structure than I would see if I'm using my 10 or 12 inch scope this is all in a dark sky site, obviously, so at the LMDSS. I don't think I would see that much structure through my scope, but certainly you would through the 40. You can definitely see that sort of irregular, the sort of lopsidedness of the galaxy through visually. You don't have to use a camera.
All right, so we've just had that confirmed by the Deep Sky Section Director that this is what you would see through the 40. I'm glad he's watching tonight. He's confirming all of our suspicions. That's good. Steve, at least it means you know what you're on about.
Some of the time.
Now, Tommy from Germany has said it's been a really very interesting and informative. Thanks, everyone. Tommy, spread the word far and wide. We are in lockdown at the moment in Victoria. Actually, New South Wales is as well. So I think something like 15 million Australians are in lockdown at the moment, Tommy. So spread the word far and wide, because there is no doubt that we will be doing one of these again next Saturday night. So let as many people know as you can, because we would love to talk to and share this with all of those people. Anne-Marie, what do you say? Anne-Marie's NGC 300. You're going to go and image that one, are you, for us, Anne-Marie?
Yep, it'll take me a couple of minutes, so I'm just placeholder.
Can we fill the void for? Can we just talk shop, or sort of like
there you go
for a few minutes? No, don't spoil the fun. We want to see it live. We don't want to see finished images. I'll tell you what. While we're waiting, let's have a look at Jupiter. It's not a galaxy, but hey, it's all that Lee can give us at the moment, and it's gone.
It's gone. Hang on, you can still see it on the guide scope.
There we go.
There
While we're waiting for Anne-Marie to bring us
we
another
go.
galaxy,
There we go.
let's have a look at Jupiter, shall we?
There's some of the 3 of the Galilean moons there.
3 of the Galilean moons. It is absolutely not a galaxy. But while we wait, we need to fill. We're going to pad out a little bit, so we'll do what we can. We've got Andy. Andy is imaging the sculptor at the moment. Have we done sculptor? I've lost track of what we've looked at and not looked at tonight.
Yeah, I normally mark them off on the page. Sorry.
I think Sculptor's one of the only ones we haven't done.
There we go. How
It's
good is
interesting.
that, eh?
Just while we're there, I know this isn't galaxies, but what the hell? We should actually be able to see the 4 Galilean moons. So we've got Ganymede is the furthest out, then Europa, then Io, interestingly, and then in the flare of Jupiter, and very close to it, is Callisto. So Callisto must be either around the front or the back at the moment. So that's interesting. It's a wonderful thing, Sky Safari, isn't it?
Yes, Stuart. Jupiter is absolutely a failed galaxy. It is tonight, anyway. We're just waiting. Yeah, so we've got 2 galaxies waiting, and Lee has clouds, and he can still see Jupiter. So we've kind of just thrown that one in there.
It keeps popping itself. See, it's just
there
all of these little stretches of clear sky, and that's what we're looking at right there. So it's probably,
now,
it's going right back in now.
Because our Deep Sky section director has been on the chat so much, the jewel box does look good in the 40-inch. It really does.
Jewel box, never heard of it.
Well, I don't think it looks as good in the 40 as in a smaller scope, because one of the challenges is that the jewel box looks nicest, I think, when it's not too big. And you can't see too many of the stars around it. And then you get to see a really nice cluster. You get to see the capital A asterism. So I don't know whether the 40 is a good scope to look at the jewel box. Paul, what do you think?
Look, our previous past president asked us to bring back the galaxies. So we will bring back the galaxies. We are, Steve, we are waiting for Anne-Marie, who is fighting a little bit of cloud, to get, I think it was, what were you going to bring up for NGC 300? And we're waiting for Andy to bring up Sculptor. So we're just flying by the seat of our pants at the moment. So doing what we can for everybody. I'm not sure. Anybody else got anything to say about this one? I can't remember which galaxy this is anymore. Everything's moving so fast now.
Is this 55?
This is, I think this is still 55, isn't it, Anne-Marie? She's on mute and she doesn't realise.
Yeah, it's 55. I've got cloud. I've just tried a couple more and I've got cloud both ways. So.
Oh, damn that evil cloud. We've done so well tonight.
We have done well, considering.
We have. Considering what we've been dealing with, we finally got Andy saying a couple of minutes and he will have Sculptor Galaxy for us. So I'm not sure if we can...
I'll try one more.
If we can, so, Sean, thank you for sticking with us. It is different from when you were a member. I'm assuming you were a member a while ago. The world is a different place and the ASV is a different place. We are trying to be as proactive and out there as we can with live streaming, events, you name it. We're trying to cover off as much as we can from a social media point of view and just keep not only our members but the general public informed of what's happening and what we're up to and what we're doing. Our Deep Sky section meetings are are wonderful to get to now. And Paul, who is our Deep Sky Section Director, does a great job. Steve comes along to those as well. The astrophotography section has always been a great part of our society. We've got a new section director as of this year. Oh, look at that. There we go. So Sean was a member prior to buying the LMDSS. Sean, it has changed dramatically since you were last a member then. We are doing astrotourism now as well. So we've had our previous, we had Wine Under the Stars, which was out at Shiraz Republic Winery. We took telescopes out there, and that was a great success. We've had I'm just trying to think now. There's been a lot that's happened probably in the last 12 months. We've done a lot of live streaming, a lot of online events. We've done a lot of in-person events. We're doing a lot of events at Caulfield Racecourse Reserve now as well. We have, hoping lockdown ends, we have an event at Melbourne Observatory on the lawns there on the 21st of October, which is now sold out. And hoping lockdown ends and we can do that. That's part of National Science Week. So we are being as proactive and forward-thinking as we can, and trying to do as much as we can to engage the public and share astronomy with them. So we are different to what we were, heck, even 3 or 4 years ago. It's a very different society now. Anne-Marie is out. She's got clouds. She's gone to check a few things. So we're now, Andy, we're waiting on you. Can we jump on your stream yet? Is it possible yet? He's shaking his head no. Yes, we can. Oh, there we go. Look at that. So this is, I've got to scroll up through the chat now. This is Sculptor Galaxy.
Sculptor.
Yeah,
at the moment it's only 2 minutes. 2 minutes on the Sculptor. Just trying to run 2 programs. I'm running Backyard EOS because I'm in my backyard, and I'm running this Deep Sky. And it's a little bit crashy, but it's working. I crashed 10 subs before, so
all right, Steve.
completely disappeared.
Stephen, this is all yours.
It's a sort of artifact from a modded camera, having the IR filter. A lot more red comes through, and it would be nice to see it in black and white, which I can't in this program. But it's, yeah. But anyone else got anything on the Sculptor Galaxy? It's quite low on the horizon at the moment. It's on the eastern horizon. Not very high, but I've got a very clear view of the east. Unless a sheep walks in front of it, of course.
It's possible. So Andy's out near the South Australian border. He's in Victoria, but he's close to the SA border. Yeah, Steve and Stefan, this one's all for yours now. Sculptor Galaxy, go.
Sure. So this is actually a fantastic galaxy to image. It's one of the brightest galaxies in the night sky, and it's relatively large as far as galaxies go, at least for us in the southern hemisphere. From end to end, it's around 1/2 degree in size, so it's about the same size as the full moon. So with any modest astrophotography equipment, it will make a great image. And it's one of the first galaxy images that I remember taking where I was really, really just blown away. So it's an intermediate spiral galaxy. It has a small bar near its galactic nucleus. And it's around 11 to 12 million light years away, of course, in the constellation Sculptor. It's a little bit smaller than the Milky Way at around 90,000 light years in diameter. But it's also a very, very active starburst galaxy. There have been a number of very, very active regions observed in this galaxy, a lot of what we call superstar clusters. So sort of open clusters where a lot of new stars have been formed, but very, very big stars, very, very high energy, and lots of them in the same area. There are also a number of Wolf-Rayet stars that have been observed in this galaxy. And Wolf-Rayet stars are basically very, very massive stars that are coming towards the end of their life, and they're eventually going to explode in a supernova, but they're not quite at that point yet. And in addition, in the center of the galaxy, there is evidence of a supermassive black hole, which is around 5 million solar masses. So about the same size as the supermassive black hole at the center of our own Milky Way galaxy. Also, much like our Magellanic Clouds, there is a small satellite galaxy of the Sculptor Galaxy, which orbits it, and it's actually thought that it's not going to survive its next pass next to the Sculptor Galaxy. The Sculptor Galaxy will likely actually tear it apart and eventually engulf it.
That's a bit sad.
That's one way to look at it.
Yeah, it's a little bit sad. It's going to get...
It's the circle of life.
I know, it's the circle
All
of
things
life.
must come to an end.
Yeah, Hakuna Matata and all that, circle of life. It's still a bit sad. Steve, do you have anything to sort of brighten that up a little bit, or are we just going to finish that one on that downer there?
Well, just a little upper for Linda. This galaxy was discovered by Caroline Herschel, who's the sister of William Herschel, back in 1783. So just evening things up. I know that in particularly bygone years, that astronomy was dominated incorrectly by men. There were a lot of good women out there doing really good work. So Caroline Herschel.
I think that might be the end of the night then. We'll end on that high note of women in astronomy and STEM. And I think I don't think we're going to have any other clear skies, and we're not. So we will jump back to us and say thank you to everybody for coming along tonight. And just sorry, I'm reading some of the comments on the side. I'm like, brighten it up. Same fate for the Milky Way and Andromeda. Yes, that is true. But yeah, thank you to the team tonight for being able to live stream through some patchy cloud. It was better than it has been for probably the last 3 weeks, but it's still not great. I dare say, again, as I said earlier, we're probably going to be in lockdown more than 7 days. So I'm tipping we're going to be in lockdown next weekend. And if that's the case, we'll be doing a live stream next weekend. It won't be Galaxies. There'll be something different. We'll work up something. There's no Guardians of the Galaxy Volume 3 out yet, so it can't be that. It'll have to be something different. So Star-Lord will say bye for now, and Drax the Destroyer will say bye for now, and so will Yondu and Anne-Marie, who was Gamora. And then we got Rocket, and I am Steve.
Steve.
Look, we have a lot of fun doing these streams. We enjoy bringing these to you guys. It is great fun. If there are objects that you would like us to try and bring to you, please pop them in the chat, send us a message, send us an email. We'll do what we can to image those objects for you. Maybe that's what we could do next week. Maybe we could do a live stream requests from people, from those who have watched our streams. You know, we might pop a poll up on our Facebook page and ask people what they'd like to see in the live stream, and see what we can do about doing that next weekend, because I'm pretty sure we're going to be in lockdown. So thank you, everybody, for joining us. Thank you, everyone here tonight, for streaming with us. Thank you, Lee. Thank you, Andy. Thank you, Anne-Marie. Thank you, Stefan. Thank you, Steve. And Caleb,
See
who
ya.
ran off early because he ran out of things to do. And unfortunately, we will see you. We will see you next. Actually, before we go, I want to see a comment. Is it a silly request? I don't know if that's so silly. That might actually be possible. Andy, is that
I've
possible?
got one of my
No, like a
my
live.
cousin took. My cousin took
No.
a
I'm
live
talking
comment.
live.
No,
Live. You reckon we could do one live?
a live comment.
Yeah.
Have to see what's around at the moment.
I might speak
There are
to.
a few.
Yeah,
We've got a couple of people we can speak to tomorrow. It might not be that silly, so we will ask the question. We'll see what we can do. But pop what you want to see in the comment section. We'll put a poll up during the week, and I think next Saturday night we will just do a what do you want to see live stream. Pick an object in the night sky. Make sure it's visible for us. So we're talking winter into autumn in the southern hemisphere, and we'll see what we can do. We'll see if we can bring it to you. But other than that, thank you very much for tuning in, and we'll probably see you next weekend. See you later.
Ciao.